Compound inequalities get a little tricky. All they are just two inequalities that you put together using the words and or. So an example is down below. So we've got this inequality, x is greater than or equal to 2. And then we have this other different inequality, x is less than 5. So what numbers are in that intersection point? So 3 is greater than or equal to 2, and it's also less than 5. So you see down here, they've got this intersection part. And any number that is both greater than or equal to 2 and also less than 5 works in what we call a compound inequality. So it meets both rules of the two other inequalities. Then we've got this other thing where we have this thing called a union, or what we would say is an or statement. So we've got or is a union, and is the intersection. So this one is a little different. As long as it is in one of the inequalities, then it's what we call in the solution. So y is less than or equal to -2, so that's all these. Y is greater than 1, so that's all these. So any number that is in either of the inequalities is in the shaded solution area. So it's not like over here where you have to be in both. As long as you're a number that's in one of the two inequalities, you can consider yourself shaded. That's the difference between an and, which is an intersection, and an or, which we call a union. So let's just first start off by writing these word sentences as inequalities, and then we'll graph it. So this is one of our intersection and inequalities. So it's going to be a joining of the two inequalities. So let's just write them separately first. X is greater than -8. X is less than or equal to 4, right? So those are the two sentences. Now I'm going to join them together. So you can either just write X is greater than -8 and X is less than or equal to 4, or you can put it in this format where you join them together, this right over here. So the way that you do that is you put the smaller number first, so -8, and then it has to be -8 has to be less than or equal to x, oh, not equal, just less. And it also has to be less than or equal to 4. So this is one way you could write it. This is the more advanced way to write it. I would encourage you to write it the more advanced way if you understand that. If you want to just write it separate, that's fine as well. And then last thing we have to do is turn it into a number line. So I've got -8 and I've got 4. I'm not allowed to be equal to 8, but I am allowed to be equal to 4. And it's all the numbers that are between -8 and 4. Alright, moving on to letter B. A number y is at most 0 or at least 2. So this is an or statement. So we can't actually join these. We can't do the advanced joining. We have to write them separately. So we have y is at most 0. At most is another way of saying less than or equal to 0. Or y is at least 2. At least 2 means it's greater than or equal to 2. So this is the only way to write an or statement. You can't join it. And let's do our number line. So we go in order. So 0 is on the left, 2 is on the right. I'm allowed to be equal to 0. I'm also allowed to be equal to 2. I'm less than 0. And I'm greater than 2. So one way that you can also remember the differences is when I first started teaching years ago, I worked with a teacher. He used to call this wings and strings. Strings is typically the and wings is typically the or. So if you look at the pictures, the number lines, you see these kind of look like wings where they're going out to the side, and strings is in the middle. If it helps you, great. If not, you can forget it. Just like earlier in this chapter, the way that you solve an inequality is very similar to the way that you solve an equation. So we're going to just drop a line down the symbol, but in this case there are two symbols to drop it between. And you have to do the inverse to all of the sides. So we're going to add 2 here, right, because that will get the variable by itself. I have to add 2 on that side, and I have to add 2 on that side. You have to do it in all of the spots of the inequality. So this gives me negative 2 is less than x, which is less than 5. So that's my answer. So x has to be between negative 2 and 5. This is going to be a strings because it's a combined or statement, or it's a combined and statement. So negative 2, 5, and I am not allowed to be equal to either of them, and I have to be between negative 2 and 5. So that's my graph. Letter B, same idea. We're going to drop lines down the inequality symbols, and I'm going to do the inverses. So I'm going to subtract 1, and you have to subtract 1 everywhere. So I get negative 4 is less than negative 2, x, which is less than or equal to 8. Now, be careful. I'm going to divide by negative 2, and what do you have to do when you divide by a negative number? You have to flip the direction of the symbol. So I get 2 is greater than x, which is greater than or equal to negative 4. So the numbers are backwards, right? Usually negative numbers are on the left and positive numbers are on the right. So you can reorder it if you want. You don't have to. But that's what it's going to look like. And then we've got our number line. But you do have to put the number line in order, obviously. So negative 4 goes there, 2 goes there. X is not allowed to be equal to 2, but it is allowed to be equal to negative 4. And x is between negative 4 and 2. Alright, example 3 is going to be an or statement, so that's going to be a wings, so that's going to kind of be the ones going out to the sides, but let's just solve it like a regular equation. So I'm going to drop a line down my 2 symbols because I have 2 different inequalities, and I'm going to solve them separately. So the first thing that I'm going to do is just going to solve this inequality all the way down to the bottom. Then I'm going to solve this equality, go all the way down to the bottom. Then I will graph the solution. So it's a little different than the other one where you were solving them all at the same time. Since you have 2 separate inequalities, you're going to do them separately. So add 5, add 5. I get 3y is less than negative 3. Divide by 3. I don't need to flip the symbol because I am not dividing by a negative number. So y is less than negative 1. Now I go over to this other inequality and I solve it. It's totally different. I'm going to add 1. I get 2y is greater than 6. Divide by 2. I get y is greater than 3. So y is greater than negative 1, or it's greater, y is less than negative 1, or it's greater than 3. So now we make our number line. Make sure you put the number line in order. Negative 1's on the left, 3 is on the right. I'm not allowed to be equal to either of them. I'm less than negative 1, so that goes to the left. And I'm greater than 3, so that goes to the right. Alright, let's check out a word problem. Electrical devices should operate effectively within a specified temperature range. So they give us actually over here on the side, they give us this temperature range, 0 to 35. Outside that operating temperature range, the device may fail. So it might be too cold for the device to work, or it might be too hot for it to work. And be careful, these are in Celsius, so it's not 35 degrees Fahrenheit, which is still very cold for us. Write and solve a compound inequality that represents the possible operating temperatures in degrees Fahrenheit of the smartphone. So the first thing that we need to do is first we need to convert these into degrees Fahrenheit. Holy cow, how are you supposed to do that? So I will tell you that the formula for converting Celsius to Fahrenheit is F equals 1.8C plus 32. So pause for a second, pause the video, and I want you to just calculate what 0 Celsius is and what 35 Celsius is as Fahrenheit values. So I've got 32 degrees Fahrenheit and 95 degrees Fahrenheit, which makes sense because, if you've ever brought your phone to the beach, it gets very hot and then it's like, sorry, you can only call 911, right? You get that emergency screen. So what we want to say is the value of the temperature has to be between 32 and 95. So the way that we write that using a compound inequality is 32 is less than or equal to x, which is less than or equal to 95. So if we're under 32 or greater than 95, the device isn't going to work. Now we describe one situation in which the surrounding temperature could be below the operating range and one in which it could be above. So I actually gave you the one where it could be above. Do you remember when I said it might not work if it gets too hot? If you're at the beach on a hot day, it might not work. What do you think might be a time when it wouldn't work if it's too cold? The example I came up with was if it's snowing and your device falls in the snow and you just kind of leave it there. Obviously, there's other issues like it might get water damage, but if it gets in the snow for a really long time, it might go below 32 degrees. If you have any questions, write them down and ask me when you come to class.